Hello everyone, in this recording what I'm going to be looking at is graphing trig functions, in particular cofunctions, and in this specific example secant graphs. So it's the same. I'm going to review the ideas of using transformations to graph a modified secant equation. So like with when we graph other equations, we want to figure out our amplitude, our period, our phase shift, and our vertical shift. And in general, we have this equation. If I have y equals a sine w x minus minus pi over phi. And so this is our general way of looking at a trig function and understanding where we can find our amplitude, phase shifts, etc. So with this secant graph, the first thing I'm going to do is I want this x to have a coefficient of positive 1, which means in this case I'm going to factor out my 3. So 3 times x minus pi over 6 now. Now from this I can tell most of the information that I want. My amplitude is going to be 5. My phase shift is going to be a pi over 6, and in this case, pi over 6 to the right. Again, because with the horizontal transformations, it has that inverse effect. For subtraction to the right, addition to the left. Now in this case, my vertical shift, there's nothing being added or subtracted outside of this parenthesis. So in that case, we can assume that the vertical shift is 0, or there is none. And now my 3 becomes my w. And when we're talking about secant, we have a period of 2 pi. So I'll say 2 pi over w. And in this case, I have 2 pi over 3. So this is my new period. And again, from this information, we're going to make our graph. And what I like to do is let's examine what the graph looks like normally if I haven't adjusted anything for phase shifts, etc. And basically our graph, let me sketch one period. Since it's based off the cosine function, it's going to have asymptotes at pi over 2, 3 pi over 2, and at negative pi over 2. So for one period, this is what I consider, and my graph looks like so. And it intersects this axis and down here at 1, and then down here at this level at negative 1. So this is the basic look of our secant function. So we're going to take this and I'm going to graph one period based off of my new information. So for starters, I know that my amplitude is going to affect the 1 and negative 1. So my amplitude is now 5. So these new levels, highest and lowest levels, are going to be from 5 to negative 5. Now beyond that, let me mark this here. So 1, 2, 3, 4, 5. And let me make that a little clearer. And negative 5. So it gives us a framework. Now what I like to do is use these intervals, use these asymptotes to help give us a frame of where to put this graph. It's usually a little easier than picking out individual points. So if I look back, I have negative pi over 2, pi over 2, and 3 pi over 2. This is where my period and my phase shift are going to come in. Since my period is affected by the W. So is my, I should say, so are my asymptotes. So for starters, negative pi over 2 since my period is divided by W of 3, so is this. And that gives me negative pi over 6 as my modified asymptote. And likewise, pi over 2 divided by 3, again 3 is my W, gives me pi over 6, positive pi over 6. And lastly, my 3 pi over 2 divided by 3 gives me my pi over 2. So here are my new, there we go, my new asymptotes. Now I also have to account for my phase shift, which was pi over 6 to the right. So for each one of these, I need to add pi over 6. And that's going to result in my new asymptotes. So this is going to be 0. So I have an asymptote at 0. Pi over 6 gives me 2 pi over 6 or pi over 3. And we'll estimate that, we'll say it's right about there. And then 2 pi over 2 plus pi over 6 would give me 3 pi over 6 plus pi over 6. So 4 pi over 6, or we'll say 2 pi over 3. Now 2 pi over 3, if we think of it as 3 pi over 3 would be pi, it's actually going to be just a little ahead of pi, so I'm going to say right about there. And so here are my 3 points, and they're little, as you can see, they're a little close together. So our graph's going to be, fairly thin when compared to the original. Now let me remove all this stuff up here. So again, to get these new asymptotes, what I did was I took each of the original asymptotes of a single period of secant, modified them by dividing by W, just like I would for period, and then I took the phase shift and added that, or subtracted based on whatever you have, to our asymptotes to find their new locations. And they're at 0, pi over 3, and 2 pi over 3. And just as further confirmation that this is correct, if we look back at our period, 2 pi over 3, that means the distance from one starting point of the graph to its end. So one cycle should be 2 pi over 3, and it makes sense if we go from 0 to 2 pi over 3, that is distance of 2 pi over 3, so it checks out. So now let me remove all this, because we want to have some room to graph. So I have the framework for my secant. I have asymptotes, and negative 5 to 5 is where I have my graphs, where they reach their lowest and highest points. So here's 1, and here's 2. So let me see if I can clean that up a little bit. So here are my asymptotes. Again, we have the new amplitude, 5 to negative 5, and then within that we have our graphs. And again, what I've drawn is one cycle. So again, to review, I want to rewrite this so my coefficient of x is positive 1, identify my amplitude, period, phase shift, etc. I prefer to look off the original graph and base it up from that. With secant and with a lot of cofunctions, there's a lot of asymptotes to consider. I like to move those around because they give me a nice framework of where everything should be. And then finally, plot your graph accordingly.